Hi guys, so today we'll be solving this problem called partition equals subset sum. Let's understand what we need to do. So we've been given an array of certain elements and we need to partition it into two different parts such that the sum of the first part and the sum of the second part must be equal. Okay, so here we can see we have an array of elements where zeroth element is 1, then second element is 5, the second element is 11, and the third element is 5. So the sum would be total 22. Now if we partition this into two halves such that we have 1, 5, 5 together and 11 in the second part. So we get the sum as 11. So what we need to do is that we need to partition the array into two equal halves. So for that, we ensure that we consider every element and check what is the possibility to consider it into one half or the other half. Okay. So for that, we'll be applying DFS. So in DFS, we'll be having two choices. One is considering the current element. Okay. And the next is not considering the current element. So by that, I mean, let's understand it by a recursive tree diagram. So since these are the elements that has been given to us and the total sum was 22, now we need to divide it into two halves. So we'll be dividing it so that it will be giving us 11. 11 is the subset sum. Now understanding what we need to do. So at every stage, we'll be having two choices, either to consider that element or not to consider that element. So either to consider, not to consider, consider, not to consider, consider, not to consider. So in two arrays, we'll be checking if we need to consider it in this array or maybe in this array. So we'll be checking if it is feasible to consider the elements or not to give a subset sum of 11. Okay. So if we get a subset sum of 11, we know that the second half would be formed. We are assuming that. So, okay. So since we know the total sum here is 22, and if we get at least one set of elements that have a sum of 11, which is 22 by 2, then we know that the other half would also be present. Okay. So we are keeping that faith and we are considering only one set. We are only finding the one set. If it is possible to make a set which has a sum 11. Okay. So for that, we will be having choices that we need to consider this or not, consider this or not, consider this or not, or consider this or not to form the subset, sorry, form the subset sum, which is 11. Okay. So understanding the tree diagram. So first we have the subset sum as 11. Now we need to make this 11 into 0. Okay. To understand if we have got the element or not. Okay. So at first step, we consider 5. So we can either consider 5 or not consider 5. So if we are considering 5, so the sum becomes 6. If you're not considering, it still remains 11. Okay. Now on the next step, 11. We can either consider 11 or not consider 11. So we know that if we consider 11, it will give us a negative result. So we don't want a negative result. So we don't take this step and we come to not considering 11 in the left subtree. Now we come to 5. Okay, in the right subtree, when we consider 11, we also get 0 here because in the first step, if we didn't take 5 and we only consider 11, then we get the result. So this is one of the answers which is forming one subset. Okay. Now we have two choices here, not to consider also. So we are not considering here. Now coming back to the left subtree, now we are on 5. On this level, we have two choices, either to consider 5 or not consider 5. If we consider, we get sum as 1. If we don't consider, we get sum as 6. Okay. And on the right subtree, we have two two conditions, either to consider 5 or not to consider 5. So if we consider 5, we get 6. If we don't consider, we have 11 only. Okay. Then we come to the last level. So in the last level, what do we have? 1. So 1 can be considered or not be considered. So if we consider here, so we get 0, which is the answer. Whereas if we don't consider, 1 remains as it is, and there is no further way to consider any element because we have reached the last index. So we don't have anything to do here. Similarly, if we consider 1, it becomes 5. That is not the answer. So we don't get it. Here also no elements. Here also no elements. Here also no elements. Here also no elements. And here also no elements left. So this is our tree where we are getting the answer by, okay, let me draw it with the other pen. So by tracing this path, okay, we get one answer. Whereas by tracing this path, we get the second answer. Okay. But we are in a hope that if we get one answer, then we know that second answer also exists. So if we are able to make a subset which has sum as a total sum by 2, then we know that we can divide the set into two parts. Okay. So that is the explanation for the whole program. Let's code it. It will be more clear. So I've already coded it, but let's code it again. So first of all, we need to find the sum. For that, let me just make nums.size n and a variable sum which stores the sum. So iterating through the nums and storing it in the sum. Now, first of all, we check if sum %2 is not equal to 0, then we return false. So what is this condition? This condition is that if the sum is odd, we know that we can't divide it into two parts. Okay. Otherwise, if sum is not odd, then we create a variable sums subset sum, which is sum by 2. Now then we call DFS to iterate through the whole nums and check if we need to choose that element or not. So we'll be passing subset sum as well and nums. Now I'm in a hope that DFS would give us the answer. Now let's make the DFS function. Int n int subset sum vector nums. Okay. Now in this array, in this function, uh, first of all, we check if subset sum is equal to 0, then we return true. Or otherwise, the boundary condition that we had was that if I is less than 0 or subset, sorry, if I is equal to 0, sorry, n, we are considering n here. So n is equal to 0 or subset sum becomes negative, then we return false. Okay. Now, considering that we would be having to save the sums to avoid the costliness of doing some repetitive operations, we'll be maintaining an ordered map for storing the subset sum that we've already computed. So I'll be creating MP here outside. So first of all, let me just write down the case where we'll be doing the DFS. So in DFS, as we said, that we'll be considering the element or not considering. So n minus 1 subset sum minus nums of n minus 1 and passing nums, or DFS n minus 1 subset sum becomes as it is because we are not considering that particular element, current element, and we pass it here. Now we've created an map, right? So in map, what we'll be storing is that subset sum is equal to result. Okay, we'll be storing that if we have computed the subset sum before or not, and then we'll be returning result. We also need to make a base condition, which we always do in memoization, which is MP of subset sum. If it is already computed, then we return the MP of subset sum. Okay, so let's run the code to see if everything is working fine. P of int bool. Okay, this would be boolean. Okay, so in this part, we need to find the subset sum, and then we need to make it till the end. Yeah, all right, that is working. So I hope you guys understood the problem. Do solve it, and do subscribe to the channel, like the video, and yes, thank you.